So a matrix is referred to by its dimensions. Now, the way that we write dimensions matters. So I can't just put two random numbers as dimensions. So let's do a 3, 1, and 8 going down, and a 9, 0, and 5. So those numbers are just arbitrary. But the hardest part about a matrix is understanding how to write its dimensions. Because when we're adding and subtracting as well as multiplying, you need to know the dimensions of the matrix. Okay. So what is the dimension of this matrix C? Okay, this 3 by 2. When you do a matrix dimension, it is rows by columns. Rows are left to right, columns are up and down. So my little way to help you remember it is like RC Cola, like the soda, rows by columns, RC. Rows first, column second. So there are 3 horizontal rows and 2 columns. So 3 by 2 is the dimension of this matrix C. So being able to recognize the dimensions is going to help you when we get into adding and subtracting as well as multiplying. Okay? So you refer to a matrix by rows and columns. Rows first, columns second. Okay. The only rule that has to happen when we are doing adding and subtracting is that the dimensions have to match. So as long as the dimensions match, the matrices can be added or subtracted. So the most important thing is that you can only add or subtract 2 matrices that are the same dimension. So being able to look at the matrix and know the dimensions of it is going to make it a lot easier to add and subtract it. It's okay if it's not possible. Okay. So when you add or subtract, you can only add and subtract matrices that are the same dimensions. Okay. When you add matrices, it's all based on location. It's basically just location matching. So the dimensions of these 2 matrices are what? What's my dimensions? 2 by 2. 2 rows, 2 columns. They are both 2 by 2, which means they can be added together. The way that you add a matrix is by looking at the position of the numbers. So the 2 is in the upper left. We're going to add that to the 3 that's also in the upper left. It's all about just the location. This matrix has 4 mini equations in it. They're just written separately in 2 different matrices. So we've got 2 plus 3, which is 5. And the 5 belongs in the same location at the end. So this is the reason that the dimensions have to match, because you have to put the number in the location where the other numbers are. So if the dimensions aren't the same, you can't add them. Then you just kind of hop around the matrix. You can do that in any order you want to. So I'm just going to go over to 3. So you get 3 plus 4 is 7. So the 7 goes here. Your outcome matrix, the answer that you get, should be the exact same dimension as the one you started with. If I got a 2 by 2 matrix, my answer needs to be a 2 by 2. So it's all about the location of the numbers. So bottom left, bottom left. My answer for 0 plus 1 is 1, and it goes in the bottom left. It's all about location. And as far as the math behind a matrix, they're usually not that difficult. This problem, I'm making it seem like it takes forever. It really doesn't. It's just because I'm showing you all the steps. You're just adding. 2 plus 3 is 5. 3 plus 4 is 7. 0 plus 1 is 1, and 5 plus 0 is 5. That's it. Okay. Subtracting is the same thing. You just subtract. So I'm looking at my dimensions. What's the dimension of my matrix? 2 by 1. So I got 2 rows, 1 column. My outcome is 2 rows, 1 column. So I just follow the pattern. 1 minus 3 is negative 2. 0 minus -2 is +2. That's it. It's all about location. Paying attention to the location of the numbers and paying attention to the matrix dimensions to make sure it's possible. What about number 3? Yeah, this one's no solution or not possible, depending on what your answer choices are on your test. Would just be no, not possible, no solution. Don't be afraid to pick that answer choice if they're the wrong dimensions. Also, if you're doing this in your calculator, it will tell you not possible because the dimensions are wrong. So this dimension is 3 by 1, 1 row, 3 columns, and this one is 2 by 1. Those dimensions don't match. It's not possible to do. So adding and subtracting, those are the ones that I would just do by hand, unless there's a lot of matrices that you're adding and you can get confused. As far as the scalar multiplication, which is next, and then on the next page, page 10, when we actually multiply matrices, that takes a little bit more time. So your calculator might save you time in the long run. So scalar multiplication is basically distributing for matrices. We just don't call it the distributive property because matrices are not parentheses. So what's happening here is, in the first example, that 3 is being multiplied to everything inside the matrix. It's basically matrix distribution. We just don't call it that. It's called scalar multiplication. So to do scalar multiplication, you just distribute the number into the matrix. That's it. The math is no different than a distributive property. It's just you have to multiply every number inside by the number on the outside. And that's referred to as scalar multiplication. You can combine addition and subtraction with scalar multiplication, like the example down here, which we'll do. So to do the first one, you're just distributing. The dimensions of your matrix will stay the same. You're just increasing everything by 3 times. So 3 times 1 is 3, 3 times 5 is 15, 3 times 2 is 6, and 3 times 4 is 12. You can do it in your calculator. We'll talk about how in just a minute. Now, when you're doing the addition with scalar multiplication, it's exactly like equations. You need to make sure that you multiply the matrix by 2 first, then you add it together. So you can do it one of 2 ways. You can do it all at once, or distribute first and write that down, and then add. So it's up to you. I'm going to distribute first just so you can see it. So I'm going to multiply the first matrix, everything in it, by 2. So 2, 10, and 4. Okay. Then I'm just going to bring down the other matrix. You don't have to do it this way. You can do it all at once. So you could do what's 2 times 1 plus 3. You can do it that way too if you would rather do it that way. It doesn't matter. And then you just add across. 2 plus 3 is 5. 10 plus 0 is 10. 4 plus 4 is 8. So all I did was distribute the 2 and multiply it in. The 2 does not go with the second matrix because it's not in front of it. If there were parentheses, then yes, you could distribute the 2 to everything that they're on. Okay? So that is as easy as matrices can be. But on page 10, we're going to talk about solving for a variable and multiplying. Okay, solving for a variable and then multiplying. Can I clear up any confusion about adding, subtracting, or scalar? The calculator can do it all for you. We're going to talk about that in a minute. Okay. So on page 10, let's see. On page 10, we've got some equations. We've got some variables in the top. We'll pull that up. This is how the practice problems on your worksheet and your tests are going to look. So we've got our x variable here in the first example. How can we create an equation out of the matrices that are shown to solve for the variable? Where'd you get 9 from? You're on the right track. You're very close. We are going to start with 5x.
Would it be 5x plus 11?
Equals 11. There you go. So inside of your matrices, there are equations hiding inside of them. You can solve these by guess and check if you just really want to guess an x value, or pull out the actual equation itself. So looking here, I have my 5x first. That's where my variable is. I want to focus there. So 5x plus 1 is in the same location equals 11. And that's how you build your equation. It's exactly like what we did on the other page, but instead of us adding two numbers and trying to solve what they equal, now we have a variable in there and we want to pull the variable out. So subtracting 1 would give us 10 and dividing by 5 would give us 2. So our x variable is 2. The equation is in there, you just have to pull it out. All right, what about the third one? We've got two variables here. We've got an x and a y. How do I set up? Let's do the x equation first. Yes. So you can either do that in your equation or do it first. So let's do it in the equation. So 3 times what? 2x. Okay, is that going to be in my parentheses? Okay, good. I'm going to close those. Minus 12. Yeah. So what happens in this problem, the 3 is on the outside. The 3 is also only with the first matrix, which means when I'm building my equation, I can only multiply matrix number 1 by 3. So I do 3 times 2 minus 12 equals 12. That's how I get this first equation. Now, on your practice and on your test, systems might be involved. So you might have an equation with x and y in it. So you will have to solve for the variable and plug it in. But that's kind of just how they make matrices difficult. So when I distribute, I'm going to get 6x, and I'm going to go ahead and just add 12 to get 24. And then dividing gives me 4. Okay. How do we build our equation for y? Okay. Yep. There you go. So all we did here was use the bottom example. So we still use the 3, the y, the minus, the 9, and the equals. So it's all about the location of your variable. Depending on where the location is, that just builds your equation. Matrices are just equations that are just written in a different way. So I'm going to add my 9 to get 33. So your y value is 11. When you're solving for a variable, when it comes to matrices, you might have to do systems, but that's okay. You know how to do them now. Okay? All right. Multiplying matrices takes a little bit more effort. Whenever you're solving for a variable like this one, you can't do that in your calculator because you can't type your variable in there to get an answer. However, when we multiply matrices, you can. Now, multiplying matrices is going to look a little weird. There are some rules that we have to follow, but after we do it by hand once, I'm going to show you how to do it in the calculator, which I would suggest because it's a lot faster. Okay? But you need to know the basics of multiplying matrices so you can do it by hand if you need to. So the first rule, the most important, is when you're multiplying a matrix. Okay, so to multiply. This is different from scalar multiplication. I'm not doing a number times a matrix. I'm doing a matrix times another matrix. So to multiply, the number of columns in the first matrix must match the number of rows in the second matrix. So multiplying matrices is going to give you a different sized matrix as your final answer. So when we add a 2 by 2 and a 2 by 2, our outcome is a 2 by 2 matrix. But when you multiply, you get a new dimension, unless they're 2 by 2 and 2 by 2, or 3 by 3 and 3 by 3. So multiplying a matrix, you have to check that it works first. You don't want to waste your time typing it into the calculator if it's not possible, because it does take time to type matrices into your calculator. So let's check the dimension. So what is the dimension of our first matrix? 3 by 2. Good. Remember, it's RC cola. Rows by columns. Rows first, column second. Second matrix, 2 by 3. So the way that you know it's possible is the number of columns in matrix 1 has to match the number of rows in matrix 2. So when we look, we have the number of columns in the first matrix is 2. Okay. It has to match the number of rows in the second matrix, which is the first number. If they match, then matrix multiplication is possible. That's the first step. If the dimensions don't match like that, you can't do it, and it's not possible. Okay? So it's better to recognize it's not possible before you type it all in. The way that you get the outcome, okay, the size of the new matrix, is you cross out what repeats. So the 2's are back to back. So I cross the 2's out, and what I'm left with is my new matrix dimension. So my answer should be a 3 by 3 matrix. Some of the problems on the ACT are just going to ask you, what is the final dimension of the matrix? You don't even have to multiply it. You just have to know that the number of columns in matrix 1 has to match the columns in matrix 2. Then the repetition cancels each other out, and the numbers you're left with is your new dimension. So now we can actually multiply. Right? Multiplication is a pattern. So when you're solving the multiplication problems, your left hand should go left or right hand should go down. So it goes like this every time. That's it. That's it. Okay? So to do this, you start at the first row. So I'm going to start at 5, 1. This is row 1. Okay. I'm going to do my math here. You are basically going to repeat yourself 3 times, because you do this for every number of rows you have. Okay. The way that you multiply is you start at the top row, and you start at the first column. You do 5 times 1. So 5 times 1 plus, and then you shift right and down, plus 1 times 4. So again, I do 5 times 1 plus 1 times 4. So 5 times 1 is 5, plus 4 is 9. Then I stick with row 1. I repeat the process until I have gone through all of my columns. So I've done column 1. Now I shift to column 2. Then I do 5 times 3 plus 1 times 6. So 15 plus 6 is 21. I still have one more column, so I'm sticking with my row, row 1, shift columns. 5 times 1 is 5, plus 1 times 5 is 1. So I got 1 times 5. Multiplication is tricky. The reason that the number of columns has to match the number of rows right here is so that this process can happen evenly. If the numbers are mismatched, you don't have anything to multiply by. That's why it's not possible. Okay? The 3 numbers that you've come up with here are now the first row of answers. So those numbers become the new row in the order that you see them. So 9, 21 is in the middle, and 10 is at the end. To get the second row in your final matrix, you repeat the same pattern, but with the second row of the first one. So the math is just multiplying and adding. It looks really weird. I highly suggest you do it in the calculator, but sometimes the ACT and on our test, it will ask you questions that you can only know by doing it by hand. So it's important to just know the basics so you can appreciate what the calculator does. So now we're going to hop here. I'm going to do the process all over again. I've already used row number 1. I repeat the same pattern, but with row 2. Okay? So my pattern starts, I start with this 0, but I start back at column 1. 0 times 1 plus 2 times 4. So these cancel, and you get 8. That number represents the first number in the new matrix. Okay? It's very repetition, like it's just repetitive over and over. Right? It can take a lot of time. Now to get the second number here, you go to the second column, sticking with the second row. 0 times 3 plus 2 times 6. 0 times 3 plus 2 times 6. So you get 12. And 12 is your middle number. It can be very repetitive. Okay. Then to get the last number, you shift to the last column. 0 times 1 plus 2 times 5. Is 10. And that's how you get this column, or this row. So take a second and try to see if you can get the very last column. Or this last row, I guess. I need to stop messing with it. So we're going to get this very last one. You can write the math out if you want, or you can kind of stick with it in your head. It's whatever is easier for you. So take a second and follow the pattern. Your left hand should be going right, your right hand goes down, so it's just a pattern.